always been fascinated by how meaning emerges from complexity, whether in stories, music, or intelligent systems. This curiosity led me from creative writing to programming, and eventually to artificial intelligence, physics, and mathematics. Now I'm interested in applying compositional modeling to understand human adaptation in space and solve engineering challenges in space exploration. Hi, my name is Haider, and I'm currently a junior at Bella Vista High School in Fair Oaks, California. I'm strongly interested in compositional modeling, artificial intelligence, and human adaptation in space. I'm excited to apply to the SEAS program because I want to explore how data, mathematics, and biology can help us better understand both Earth and the future of human space exploration. What makes my journey unique is that I didn't always see myself in STEM. Instead, my curiosity has always been driven by creativity. I spent most of my childhood drawing characters, making phones out of cardboard, composing music on my iPad.
Go and zoom in. I don't know why I run away.
And writing stories. When I was 13, I began writing a novel. One draft became 40 pages, then 60, and eventually over 100. The story became a published book, and the sequel was published a year later. Creation felt instinctive to me. STEM did not. I even taught myself basic programming and built small text-based games, but it still felt too procedural to capture my curiosity the way writing stories did. But that changed during my first year of high school when I took AP Computer Science Principles. I realized that programming involved more creativity than I thought. Designing and debugging a program felt like shaping a story, imagining possibilities, testing outcomes, and refining them. Near the end of that year, I discovered neural networks. I was fascinated by how machines could learn and recognize patterns, and I quickly realized I lacked the mathematical foundation to understand how they worked. I wanted to know how meaning could emerge from mathematics. When I searched for answers, I found myself staring at symbols that only confused me. Instead of giving up, that confusion became motivation. I went back to the foundations, relearning algebra, then pre-calculus, and eventually calculus, asking why at every step. I spent entire days working through problems to understand the concepts. Gradually, math stopped feeling like a school subject and started feeling like a language I can think in. As calculus began to make sense, so did optimization and machine learning. I found myself debugging gradient errors from morning to night, feeling the same focus and absorption I once felt while writing stories. That same year, I took AP Physics, which helped me connect abstract mathematics to the physical world. My teacher's passion for the subject inspired me to ask why behind everything, and I started exploring the answers myself using physics principles. The following year, in AP Biology, I tried the same approach, but many questions went beyond the scope of the course. I persisted, asking deeper questions. I craved understanding the why, and I still do today. These experiences deepened my appreciation for how models and equations describe real systems and broadened my perspective as I began to notice connections between computational systems and biological processes. When school returned after COVID, I still struggled socially, but curiosity became a bridge. I started an AI club at my school, even though I wasn't sure anyone would come. The first meetings were awkward, and so was I, but over time explaining ideas on the board and listening to others reason through problems helped me find my voice. The club grew into a collaborative space where students explore machine learning, programming, and problem solving together. Through this experience, I realized that leadership is not about having all the answers or being an expert, but about creating an environment where curiosity and exploration are shared. I wanted to take my learning further, so I volunteered at a summer workshop hosted by Humanity Beyond Barriers as a guest speaker and assistant working alongside experts.
All of the images can be represented as vectors, very high dimensional because of how many training examples there are. And they can be groups and clusters, like maybe like one cluster there.
Presenting concepts like neural networks, large language models, and diffusion models to over 50 students was challenging. I had to figure out how to make complex ideas clear without oversimplifying them. Through this, I learned to explain things more concisely and adjust my explanations to different audiences.
We start at a random state where we have a very noisy image, and that's like some random place in the image space. What we're trying to do is navigate through this image space and get to a cluster.
My curiosity also led me to formal research. A project I worked on has been accepted for publication at an IEEE conference. Working with my research mentor, Dr. Ahad at Georgia Southern University, I learned how to design experiments, analyze data, and communicate results. I'm eager to apply these skills to studying human adaptation and compositional modeling in space research. I'm excited to bring my curiosity, creativity, and persistence to SEAS, applying computational modeling to explore how humans adapt to space environments while helping build collaborative spaces where exploration and discovery are shared. I want to continue asking questions, connecting ideas across disciplines, and turning curiosity into action. Thank you for considering my application.